Hi everyone. My name is Joyce Aigbokhan, and I'm going to be presenting our final demo for our project. This is Red Table team, and my team members are Sai Swaroop, Rakesh, Hemanpreet, and Shivani, and my humble self, Joyce. I want to move to the next slide. Like I said, this is Red Table. My team members are Rakesh, Shivani, Swaroop, and Hemanpreet. I want to first of all thank use this medium to thank Dr. Saros for giving us the opportunity to learn, how to use big data system. It wasn't really easy. It was really challenging for us because after the spring break, it was really challenging because the coronavirus came up and we had to work individually, and but we were able to figure out how to work as a team via Zoom and Team Viewer. But we were able to work on our projects and deliver all the tasks that was required. I will we actually learned a lot, but I want to go to the next slide. I'm going to be talking on the project management aspect, which is Jira. I'm going to start with that. So this is our PEP chart for the sprints, was all the sprints from January to May, from the first to sixth sprint and our final demo. So this is our Jira chart for the whole of the project. First, we started in January. We started with Jira setup, which took us 1 week to execute. We later move on to the deliverables, which took us 15 weeks. As all through the sprint from January to May. We had to do sprint 1 deliverables, which are the PEP charts, the required deliverables we need for each of the sprint. It took us the whole of the sprint to work on. And then we moved on to database, which took us 14 weeks because we had to work on our database, and this happened within the space of February. We move on to the next one, which is the use cases, which took up 7 weeks to work on. Then we started that same February, we started our Power BI, implementations. Strategy and implementation, which took us 6 weeks to deliver from February to March, also in April as well. Then medium plus record on Python started in the month of March, took us 4 weeks to execute. Then we'll move on to the next one, which is the DDBS design, which took us 8 weeks to deliver. Then we're moving on to our next one, which is a DDBS implementation. It took us during the course of March and April. We were able to work on DDBS design and DDBS implementation. Because of March and April, we worked on that. Then we moved on to the last one, which is the final demo, which we were presenting today. It took us just 1 week to prepare, But for the DDBS, it took us 5 weeks to be able to implement our DDBS on. So I'm moving on to the next slide. We have our Jira workflow. As you can see, we had this is actually epics. You can see our epics, and under epics we have all our child issues. Pretty much everything was done during the course of Spring 1 to Spring 6. We're able to execute all the taxes. You can see Jira setup. That's for the first week, which I showed in a PEP chart. Jira setup, setting roadmaps, PEP charts, Gantt charts. So this is pretty much our first week deliverables, which we executed. Then we started with the next one, which is database. You can see reverse engineering, data objective. All the child issues on the database. We also have our deliverables. You can see we have sprint 1 to sprint 6 deliverables, and our final deliverables was also among the deliverables which we were able to work on and execute. Then you have our use cases where we have, you can see one our epics cases. On our epic we have use cases, and under the use cases we have several child issues. Implementing our use cases, 5 to 6 use cases, 10 use cases from instructor was given to us by Dr. Cyrus, and 5 use cases was implemented. All Then we also have another epic, which is use cases, continuation. Then we also have our Power BI epic, which we have our Power BI implementation. We learned Power BI, Then we also have our million plus record. Under that child issues, we have our expansion of strategy, expansion of implementation. Under what we have DDBS, we also have a DDBS design strategy. Then we have a setup Docker, though we had some issues, trying to be able to access it, but that was just that. Then we also have a DDBS implementation, child issues under it. We have a DDBS implementation strategy, connecting server using Docker, which I just talked about now. Then we also have our DDBS Power BI epic, and under that we have child issues under the DDBS Power BI. Then we also have Python, which we also work on. So that's how our workflow looked like. So moving on to the next slide. So this is our project roadmap. We have our project start date, which we had to learn how to use Jira and Trello, for efficient project management. We added multiple sprint, backlog, roadmap, stories, tasks, issues, design, pep chart, grant, and burn-down charts to see the current working status for teams and all that. So we have a sprint setup. That was this. Sprint setup was just for the project start date. We also have a sprint 2, which we learned about the fuzzy attribute, range, categories, and decisions about using analysis and queries based on the listing of employee. Decisions made about their performance, related sales for far through SQL. That's what we did during the course of sprint 2. Sprint 3, we combine and analyze data for SQL, Oracle, and through pivot by developing a data modeler. Then sprint 4, we redesign and expanding of database and making changes to develop the DBS strategy based on horizontal and vertical fragmentation. Sprint 5, we consider the concept of concurrency, control, DBS strategy, and implementation fragmentations of database according to the strategy. Sprint 6, where we working with the Docker, coming up with use cases using develop database and linking up with server. And our final demo, which we're working out well, compile all those sprints which were worked on, the Scrum repetitive document, and developing the links. So I'm going to move on to the next slide, which is our Gantt chart. So this is pretty much our Gantt chart, which shows the process of all our charts, or all our projects. You can see the epics and the child issues. So you can see most of the child issues were all done, and you can see the epic right there, written boldly. And with all the assignees also, you can see all our names right there. This is what we did as a team. Moving to the next one, we have our abundant chart. As you can see, for all sprints, so I have to collate all sprints together, sprint 1 to sprint 6. You can see all the levels of abundant chart that was on. Thank you.
After going through the project management software Jira, let's move on to our fuzzy database. Where this is our data modeler. As you can see, there are two different types of tables, blue and yellow. And blue represents our fuzzy tables, which are not linked with any non-fuzzy attribute, and weight tables are present, which we cannot see in SQL but in Oracle. We will use this database to find out best employee performance and other queries. So moving on to our next slide, where fuzzy database has While studying the database, we found that it has 6 membership sets. So 101, 102, 103, 201, 202, and 203. And the 2 rule sets, triangle and trapezoidal, which gives 12 decisions per employee. And those 2 rule sets, out of which 1 rule set has 25 rules, and the rule set 2 had 125 rules. So for these, triangle and trapezoid are the 2 fuzzy relationships, which also has its own fuzzy metrics, which helps in evaluating the employee's performance on the basis of 5 fuzzy categories, which are poor, below average, average, above average, and excellent. With these, we can see what can employee as a decision get, like raise and promotion, a fire employee, give warning, no decision, etc. So explaining more about fuzzy, with the implementation of fuzzy queries, we visualize them with the pivot. As you can see, from these analysis, we learned that rule set 2 is more beneficial for the company with respect to the rule set 1, as it had less number of decisions, which gave no decision and fire employee. So moving on to our next slide, where we worked on data generations through Python. So this is our code, that the main code that we used in our Python program, and we generated records for both orders and order lines from 2004 to 2020. To expand the database, we ran 2 scripts for order as well as order line, in which we defined range for months and employee members. Which we ran a loop for, and it gave us a number of order lines and orders for all the employees for the given range from 2004 to 2020. We even took care of the leap years in between. So this is our code we obtained to work on and get the orders and order line as a expanded generation. So this is the expansion strategy, where added records yearly from 2004 to 2020 for 17 years, which we were successful in accomplishing, and used Python for data expansion, increase order numbers from all years per day, which we turned out provided more order line numbers for each year. And this expansion leads to increase in data table for like employee, customer, product table also. So we were able to fully accomplish our task as we decided as our strategy.
I, Hemanpreet, will take on from here, and I'll tell you about the OS database expansion. And for that, we used the existing OS data model, and we used the semi-structured database which we obtained from our Python script. We merged them together and we obtained our new OS4 data model, which can you see right now here. And as you can see, the ER relationship diagram of the database is almost similar to the pre-existing data model. And during this expansion, we also took care of the various factors like the orders, order line, and we also added new customers, new products, and the new employees also. So we didn't want to make an unbalanced database. And here you can see the screenshot of the orders per year. And the database is from 1999 to 2020. And the new OS4 data model, we added the database from 2004 to 2020. And all we did was by using the Python script, and we just merged it as I told you earlier. And over here you can see the total counts of per year's order made by customers. And over here you can see the order lines per year, and the order lines over here are like roughly 3 million in the count. And for that you can also see per month order lines. And for that we use the stored procedures also. So there were multiple stored procedures which we used to came up with the employee orders and the employee sales database and about their performances. And for that we came up with the various stored procedures such as above average orders, sales orders, below average sales, below average orders, excellent sales, poor orders, and poor sales. And over here you can see we divided the range for every category as according to what we thought would be correct. And over here you can see the result which we obtained from our stored procedures using the stored procedures, and it was of the employee orders. you can see for every employee, we can see the orders he did for a particular year, and what was the performance of the employee during that year, as well as the name also. Followed by the employee sales, which you can see it also explains what the employee's ID, employee year, and the amount he generated, and what was its performance with respect to the other employees. Was it good? Was it below average, poor, or excellent?
Going into the distributed database, first we have decided what tables has to go into the Oracle server and what tables has to go into the other two servers, that is the SQL Server 1 and SQL Server 2. So we had the difficulties of moving out the order line table, which has 1 million records, into the SQL Server, and we have learned about this restore and backup probability inside the SQL Server during this distributed database design. So these are the three servers that we have used for this distributed data model. One is the Oracle server, that is the Oracle SQL Developer. The other one is the Microsoft SQL Server, SQL Server 1, and Microsoft SQL Server, SQL Server 2. So one Oracle server, and so we have named the Oracle server database name as the Red team. So it's been difficult for us navigating through these Oracle servers because of the pre-existing tables and the views which has already come up with the Oracle server, that is a Docker. So we as a team decided to have the customer, employee, and branch tables into this Oracle server. As Dr. Cyrus asked us to have the horizontal and vertical fragmentations along with the replicated and solo tables. So we horizontally fragmented the customer table on 6 different regions, and vertically fragmented the employee table based on the states. So we just took Minnesota as a single state and fragmented vertically, and for all the other states we just used one more employee table to fragment it. And the replicated tables in the Oracle server are customer and employee, as you can see here. So coming into the Microsoft SQL Server 1, the database name we have given is the SQL Server 1, and we have the orders, order line, and product tables into this SQL Server 1. So this was one of the difficult tasks we have faced because of the transferring of 1 million records from the order line table, which are in our local machine inside the OES3 database into this server, that is SQL Server 1. So going into SQL Server 2, we named this database name as Fuzzy Database, which includes all the fuzzy analysis tables, as you can see here, employee fuzzy decision, employee fuzzy orders, employee fuzzy performance, etc. So here you can see the solo tables, that is which are not replicated and fragmented. Here you can see the distributed database model diagram, in which this is the Oracle server, this is the SQL Server 2, and this is the SQL Server 1. So here you can see in the Oracle server we have the tables of the customer, employee, and the branch, and in SQL Server we have all the fuzzy analysis tables, that is the fuzzy orders, fuzzy products, employee fuzzy decision, employee fuzzy performance, and so on. So, and in the SQL Server we have the tables of order line, orders, and product. So basically what we have done is we had our customers and employees in the Oracle server that are the users. We had them in the one server, that is the Oracle server, and the fuzzy analysis into the other server, and the orders, which is nothing but the sales related data, into the other server, that is the SQL. So here you can see the two SQL servers. This is the SQL Server 1 and this is the SQL Server 2, where you can see the tables of order line, orders, and product in the first SQL server, and the fuzzy tables in the second SQL server. So here you can also see the server name, academic.campusquest.com 2601. This is the port number that we have used, and we could not have the image for the Oracle SQL Developer since we have the preloaded and pre-existing tables and the views in the Oracle SQL Server, and it was difficult for us to take the screenshot of that. So coming into the linked servers, we have found it more difficult when where we don't have any admin access to generate a linked server between two Docker servers, which we have, that is the SQL Server 1 and the SQL Server 2. So what we have done is we have created link server, which links our local machine and SQL Server 1. So we have named this link server as server first, since we have all the fuzzy related data in this server. So here we have selected the server type as other data source, and provider name is the SQL Server, and the product name is the Microsoft, and the data source we have given is the server name, that is academic.campusquest.com 2600, and the provider string is nothing but server equals to server name slash instance name. That is, since the instance name is null over here, we did not give anything. And as asked by Dr. Cyrus to have the authentication, we have given user login and password for that. So here we have created another user called SA3, which is not same as SK user, which does not have access. So we have just created a user called SA3 and have just given the provided all bulk admin access for that user, and that is why we were able to create this link server between one of our local machines and the SQL servers. So we have also created one more link server called the test server to link both our Oracle local machine, which is there in our Oracle SQL developer, and the local machine of our SQL server. It's the same way as we have created this link server called the server first. It's in the same way we have created the test server. So coming to the open query, this is the query we have ran for one of our link servers. So this query talks about each and every employee performances or number of orders made by each and every employee for every year. So in our local machine, we have the OES3 database, which have all the tables, and even in our SQL server, we have orders and order line tables as well. So we have used the link server, the test server, to generate a separate report for each and every employee with the last name, first name, employee number, and number of orders, and also the year that they have made the number of orders for each year.
Hello everyone, this is Sai here, and I'll take you guys through the Power BI stuff that we did in ID 641. So we pretty much know that we have many queries listed out in our fuzzy database and also non-fuzzy queries. So starting from our phase one, we came through many queries like list the employee names and their employee name, first name, last name, their city, state, and the nations that they have been given, and list the employees from the top 10 employees from based on their sales, and also the orders of employees based on their sales. And so we have gone through many queries. So this slide is a Power BI slide that I made, which accumulates each and every query. So if you see on the left corner, I just used a slicer to differentiate all the employee numbers in this, and this is just a single row card which gives us the employee name if you select a specific employee number, and below that you can see the orders that have been placed for that particular employee, and the visualization, the column graph that you are seeing here is orders by every year. As we know that we have used the data generated data, which gives us both the orders and order lines for 17 years until 2020 for each and every employee. So so there is a query that asks to list the employees with orders for all the years. So we have used this visualization to get that. And the top right corner, you can also see the number of products that has been sold for each and every year. So so you're seeing pretty more number of products, because we have expanded products as well when the data generation is happening. And so these are the products that we have used. So this is just a multi-row card again. So if you just select each and every product here, you can able to see those particular products that have been sold for each and every year, which I'm gonna show you in the live demo at the end. And the visualization here, which talks about employee positions based on branch number. So you can clearly see that there is only one CEO here for branch 100, and the rest are all the employees for each and every branches. And if you just go to next slide, here this is just all a single query which says to list the employees based on branch number and state. So again, we know that all the employees have been divided into different years. So year wise we can see the number of employees in each branch, and we can also see the states that they are in this map in the right corner. And moving forward, as Kalsi said, that we have developed two new tables to define the employee analysis based on orders and sales. So this is the plot, the visualization that we used for employee performance based on orders. And everyone knows that we have 5 different categories for attributes here in fuzzy database. That is poor, below average, average, above average, and excellent. So we just use the slicer here for number of orders, which says the attributes or nothing but the attributes, and we used years in slicer here, and also we gave a single card statement here to count the distinct employees in each and every year for that particular attribute. So you can clearly see that there are if we just select average, there are just 3 years here which says the employees which comes under the average performance analysis. And if we just select 2007 here, we can see there are only 7 distinct employees, and the orders that has been made by that each and every employee in year 2007. So moving on, this is the Power BI visualization that we use to showcase the employee performance by sales. It is almost similar by orders. The only thing that changes here is the sales. So if we just select below average attribute, and these are the years that we get under below average attribute, and if we just select 2008, you can see there are 15 different employees in that year who falls under the below average. So it just so the pie chart just populates all the sales that has been made by 15 different employees. And then this is just an overall visualization about customers. So it just says the customer information. As we know that after data expansion, we just expanded customer table as well. So the total customers that you can see as a whole in our OES4 database is 305. And you can, in the left hand side, you can see the customer full name, state and city, and between the map, the locations of all the customers worldwide, and the amount that they have spent on each and every product for all the years. So this is just a basic Power BI visualization about customers. This is the important employee information regarding their decisions. So we just use Power BI to visualize this as well. So in the starting phases of this project, we were asked to determine the employee decision. So we just sorted out using the 6 different mem sets and 2 different rule sets for each and every employee, which brings down 12 different decisions for each and every employee. So we just sorted out those 12 different rules using the fuzzy triangle and fuzzy trapezoid rules, where we just tweaked out the memberships values in those 2 different tables, and those that helped us to land in somewhere to defining these divisions for each and every employee. And so as you can see that our main motto is to have very few less number of fire employees and less number of nodation sets. So as everyone can see here in the pie chart, that there are 16 employees that falls under the fire employee nation, and 24 employees that falls under nodation net. So we feel that this is pretty good plot that we got. And regarding the decisions like give raise to employee, we have 16, and 9 people falls under give warning to employee, and 5 employees falls under give raise and gift to the employees. And you can also see a map here in the right side beside that pie chart, where which will show the locations of each and every employee. And on the top right corner, you can also see the decision net placed in a single multi-row card, which gives us all the decisions about each and every employee. So if we just select one decision there, it's going to highlight only particular employees that falls under that specific decision. So that's it. And all these Power BI visualizations will be shown to you people in the live demo.
So okay, this visualization of Power BI works for few queries. So when you click on employee number here, right here, it prints out employee name and the numbers of orders employee has handled right here. So we'll click on any employee number right here, and it prints out a name and number of orders employee has handled right here. So in the graph, you could see the number of orders. You can see right here in the graph, number of orders handled by employee by year. You can see the year right underneath, and the number of products handled. So moving to the next slider of product. When you select a product like PS4 right here, we get to the product sold. You get to see the product sold yearly for that employee about PS4 right here. So they highlighted so they highlighted ones shows the number of PS4 sold yearly, as you can see right here. So moving to the third visualization, you could also see that the different colors right here, different colors of branches number, and only one CEO is present in every branches, and the rest employee positions are fragmented differently. Right, you could see the branches number, and you could see we have only one CEO present right here. Okay, so we're going to move to the next slide. Okay, so in this visualization, you could see the number of years for the company we're working. So when you click on one of the let's say you click on one of the years here, you could see the numbers of branches, employees and numbers of employee that works in a particular branch. So you could see how it all appears right here. So right on the other side, you could also see locations of employee in a particular branch, so you could see them right over everywhere. So thank you.
So after creating a VS4 data model for our SQL and to try to come up with employee performance on the basis of orders and the sales, in the SQL part we came over to business intelligence of Power BI to analyze it on a bit more further basis, and to have a better picture like what would be the good part. And for that we just create a basic example for that one. Firstly, let's talk about employee performance by orders. In this, as you can see, we used a pie chart basically, which has almost all the visualizations, and it will tell us about all the employee numbers in it, comprising of all the employee numbers followed by a card. And all this is all correlated with the filter of number of orders, and it has 5 attributes: below average, above average, average, and excellent and poor. And it also, so depending on the attribute we select, we can see the years on the left of the side. So as if I choose a below average attribute, I can see the years which have that performance of every employee. So year 2004, 2005 and 2006 all have the below average performances, and the count of the employees who had this kind of performance, similar kind of performance can be seen is 11 and all their names. And this is also the percentage can be seen, and the IDs also are shown in the different colors like 1058, 1059, 1115, followed by their first names and the last names. Similarly, we created another use case which was like employee performance by the sales, and this is also follows the same criteria. It has a one pie chart with the number of count of employee names with 5 attributes, similarly above average, below average, average, excellent, and poor. And it also stores the data of all the 14 years from 1999 to 2020 with of every month. And as you can see, if I choose average in this, I will see all the years who was the performance of the employee performance with the average criteria and for every year. So if I choose any year on the basis of the criteria, I can get the following result. So for this, I am choosing year 2007, and for that I can see the count of employees are 190 for the average performance, where I can see the IDs in the pie chart and like what is the total sales made by them, what's the amount they made by doing that sale. And over here you can see all the 190 names. Yep. So this is all the most of the part we did in the basic Power BI intelligence visualization of our employee performances and sales.
Coming up to customer information visualization, where we have total customers of 305, and if we select any of the customers, we can get the data from where the customer is and how many sales and the number of revenue the customer has spent in that particular area. Second, let's move on to our employee information, where we can see the employee number, last name and first name, defining our decision set for the count of number of employees. And this is the decision net, where we can actually select like if the fire employee, so this will get our 16 employees are fired in that set. So we were asked in first phases to tell about the decisions, to tell about our fuzzy database. We had 6 different fuzzy member sets and 2 different fuzzy roles sets, which will give us like 12 different decisions for each employee. And our motto was to get the less number of fire employees and no decisions. So we took the help of our fuzzy triangles and trapezoid and came up with like sort out the membership values, which gives us the following decisions for each and every employee. And you could see that, and in the pie chart, as I already told you, we can get the number of we can get the count of the number of employees by a decision set. After working from Jira project management tool, then designing fuzzy database, fuzzy attributes, and working on some queries, and then developing our own database using the previous database that we were given with using Python, we came across many difficulties and got to learn a lot within team as well as working with different teams, and that made us learn a lot from the same project. And the slide tells us what we learned. So irrespective of those designs and implementations of fuzzy database, distributed database, or data generation using Python, these are the lessons we learned. So we categorize them as team dynamics, business decisions, data analysis. So in team decisions, we actually learned working with each other through different platforms and communicating for different aspects, as well as for learning different modules, as well as solving problems. Like we were working on our OneDrives and developing our PPTs and Scrum documents, retrospective documents, which all came up through to an accomplishment, and that was a big thing for us. So secondly, for our business decisions, designing and working with different aspects in database to understand like more about efficiency in working of employee and its performance in a company, choosing variables to reduce uncertainty, like how efficiency can be increased in deciding some employees working and his performance. So that what an aspect as from a business point of view we learned. So again, for the third part, that is that analysis, some strategies and some fundamentals and principles of that analysis we were able to get through within the team, and learning across, that's what we learned. So that's it. Thank you very much. And we were enlightened by the knowledge we obtained from this subject as IT 641, and learning within classmates and guidance from Dr. Azbar was something we won't forget. So we are thankful to Dr. Cyrus for giving us the opportunity to learn under him. Thank you.